Good morning, students. In our previous class, we discussed about electron gain enthalpy or electron affinity. Now, how the electron affinity changes along the groups and periods, let us discuss. First of all, what is meant by electron affinity? It is nothing but the amount of energy released whenever an electron is added to the outermost orbit of an atom, right? Now, give the subheading as variation of electron affinity along the groups and periods. Okay? Variation of electron affinity along the groups as well as in the periods, let us discuss. So before discussing about the variation, so first let us discuss how electron affinity is related to atomic radius, right? And atomic radius. Atomic radius or atomic size. Now my question is, how these two are related? Means whether they are directly proportional or indirectly proportional. If you observe that, in the case of small size of the atom, the effect of nucleus will be more on the outermost orbit, right? So the nucleus attracts the electrons strongly towards it, okay? So smaller the size, the effect of nucleus will be more on the outermost orbit. So it is able to attract the electron strongly. When electron is added strongly, automatically it releases more amount of energy. So remember one thing, electron affinity is inversely proportional to atomic radius. Okay? Electron affinity is inversely proportional to atomic radius. What it means? As the atomic size increasing, electron affinity decreases. Okay? So as atomic size increases, electron affinity decreases. Got it? So now anyway in all these along the groups and periods we know about the variation of atomic radius. We know clearly top to bottom atomic radius increases. So as atomic radius is increasing along the group, electron affinity values decreases. Okay? So in groups if you observe, electron affinity decreases from top to bottom in groups. Okay? In the groups, the electron affinity values decreases from top to bottom. Okay? So why they are decreasing means because atomic size is increasing, so electron affinity values decreases. In periods, let us observe. As we know, while we are moving from left to right in a period, what is happening? The nuclear charge increasing. So when we are moving from left to right in a period, atomic number increasing, but the number of shells are same. So the effective nuclear charge increases. Okay? So as the effective nuclear charge increases, we know atomic radius decreases, and even smaller the radius, more will be the electron affinity value. So because of that, electron affinity increases from left to right in periods. Okay, electron affinity value increases from left to right in periods. Okay, so the reason for this is because when we are moving from left to right in the periods, nuclear charge increases. So electron affinity value, nothing but the electron will be added quickly to the outermost orbit of the atom. So it releases more amount of energy. Okay, but regarding the values, here you should be careful while choosing the options. Okay, for example, lithium and fluorine if you take. So for example, lithium is the electron affinity value is approximately it will be around 56 kilojoules per mole. Fluorine electron affinity is around minus 328 kilojoules per mole. Okay. So whether the value is electron affinity value increased or not. Here we clearly written with the discussion that electron affinity is increasing from left to right. But with these values if we observe, so minus 56, minus 328. So minus value wise if you observe, it means we know minus 56 is big, minus 320 is a small value. Correct or not? Because of the negative sign. Okay, so negative sign is common because electron affinity means the energy is released, right? So because of that fact, when they give values, you don't confuse. Okay, so forget about the negative sign. Here, left to right, what has happened? Electron affinity value increased from 56 to minus 320. Okay, here the negative sign represents the energy is released. Okay, the process is exothermic. To represent that thing, we are using negative sign. Okay, you don't use your mathematical knowledge while deciding which is having more electron affinity. Okay, so out of this, which is having more electron affinity, if I ask, what will be your answer? It should be fluorine only. Okay, forget about this negative sign because that sign represents the energy is released because the process is exothermic process. Okay, don't confuse with the values. Right. Now, let us discuss which element will have highest electron affinity. Okay, here it is not an easy thing to say this element will have highest value because there is a small twist in what you are expecting. Okay, so let us focus on in the exceptions regarding electron affinity. Okay, the first thing, let us compare electron affinity values of fluorine and chlorine. Out of fluorine and chlorine, which will have highest electron affinity value if I ask? Generally, fluorine belongs to halogens family. Below fluorine, chlorine atom will be present. Okay. So in the groups what we discussed, top to bottom we discussed that. For example, bromine, iodine, if they are present. What we discussed, from top to bottom, electron affinity decreases. Okay, so the highest will be for fluorine, we expect. But practically, the electron affinity values of fluorine is less than chlorine. Okay, understood the logic? From left to right, electron affinity values increases. We don't need to discuss about first period elements because first period contains hydrogen and helium. Helium is a noble gas. We discussed that these noble gases don't gain the electrons easily. So that is why their electron affinity values are positive. Okay? Because in the previous class, the last point we written in the notes, that one. So helium don't have highest. So next one, the right side noble gases if we exclude. The next group is 17th. So these elements are having very high tendency to gain the electron. So out of these, which is having highest means we may choose fluorine, but the answer is chlorine. Okay, the electron affinity values of fluorine is less than chlorine. Why? Okay, so this is many times they ask about this electron affinity of fluorine and chlorine. So let us discuss clearly. For example, let us go for fluorine. Fluorine atomic number is 9. So if you observe its electronic configuration, 1s2, 2s2, 2p5. Right? So in the valence shell it is having 7 electrons. Okay? So for understanding purpose, the 7 electrons in the valence shell of fluorine I represented. Now coming to the chlorine atom. Chlorine atomic number 17. If you observe its electronic configuration, it is a neon 3s2 3p5. Right? Because both are same group elements, similar electronic configuration. Here, this is also having the 7 electrons. Okay? Both fluorine and chlorine both are having 7 electrons. But what is the difference here? Fluorine is having the 7 valence electrons in the second orbit, but chlorine is having the 7 electrons in the third orbit. Okay, so which is of large size. Everyone knows that when compared to second orbit, third orbit will have more radius. Okay, but both are having same number of electrons. Right. So once observe the fluorine diagram. In the case of this fluorine, all these 7 electrons are present in the small orbit. Okay? Means compared to chlorine atom. So when the electrons cloud is very close, what happens? There will be repulsions between them. Because every electron is carrying negative charge. Between the same charges, there will be some repulsions. Right? In the case of fluorine, as well as in the case of chlorine, both the cases there will be repulsions between the electrons present in the orbit. My question is, out of the two cases, where the repulsions between the electrons is more? 100% we can say fluorine, because all these 7 electrons are present in second orbit only. So between the electrons there will be more repulsions in the case of fluorine when compared to chlorine, right? So these type of repulsions are known as inter-electronic repulsions. Okay? The repulsions between the electrons present in the same orbit are known as, or within the atom are known as inter-electronic repulsions. Inter means within the atom. Okay? So there will be repulsions between the electrons in the case of fluorine as well as in the case of chlorine. But in which case more repulsions are present? In the case of fluorine, there will be more inter-electronic repulsions are there. Right? So when they have more repulsions between them, is they will allow the another incoming electron. Because that incoming electron means the electron which we are going to add to the valence shell is also carries negative charge. So already there are very high repulsions between the electrons in the fluorine. So they will be reluctant or they will oppose the incoming electron. Okay? But in the case of chlorine, here also the repulsions are there, but compared to fluorine the repulsions are less. Okay? So they will oppose very less way the incoming electron. Okay? Here due to inter-electronic repulsions in the case of fluorine, they don't accept this electron easily. Right? chlorine. Okay? So not only in the case of fluorine and chlorine, in all these second and the third period elements, the same variation will observe. Okay? Means the electron affinity of nitrogen and the phosphorus. Same concept. Nitrogen belongs to second period, phosphorus belongs to third period. Same group elements. But the electron affinity values of nitrogen is less than phosphorus. In the same way, oxygen and sulfur, if you observe, same oxygen sulfur belongs to same group, but oxygen will have less electron affinity compared to sulfur. Okay? Regarding this nitrogen and phosphorus, we will discuss separately about this one. The same way we observe for carbon and silicon. Same concept. Carbon also will have less electron affinity compared to silicon. All these exceptions are mainly because of, due to their small size, they will have more inter-electronic repulsions. Right? So that is why they will have less electron affinity values. Okay? So let us write clearly in the notes. Highlight this one while you are writing in the notes. Electron affinity of fluorine is less than chlorine. Electron affinity value of fluorine is less than chlorine due to more inter-electronic repulsions. Due to more inter-electronic repulsions present in fluorine. Okay? So in case of fluorine, there will be more inter-electronic repulsions. That is why the electron affinity of fluorine is less than chlorine. Okay? So other examples like this, the oxygen will have less than sulfur as well as carbon will have less than silicon. Okay? So note on those two also. Next. Out of all the elements in the periodic table, the highest electron affinity will be for what? The highest electron affinity will be for chlorine. Not only. Okay? We will expect the fluorine, but the highest electron affinity will be observed in the case of fluorine. Right? Not only. Even regarding this, mention one more point. Generally, metals will have, okay, simply listen, generally metals will have less tendency to gain the electron, right? So in the metals, there will be the lowest electron affinity values. So the lowest electron affinity value in the case of metals will be observed mainly in the case of mercury, okay? Hg symbol. So in the case of mercury, we will observe the lowest electron affinity value. Because metals don't have tendency to gain the electron. Okay. Now we discussed about electron affinity completely with the definition, units, the variation, everything we discussed. Now let us solve some questions based on electron affinity. highest electron affinity value. The elements are sulfur, phosphorus, oxygen, carbon. Okay? Sulfur, phosphorus, oxygen, carbon. Now, if you observe the four options, how will you come to know which is having highest? Because we don't know the values exactly. We cannot by heart the values, right? So we need to focus on to which period or to which groups they are belong, right? So if you observe the carbon belongs to 14th group, we know. Next, oxygen belongs to 16th group. Here nitrogen will be there. Then down that phosphorus will be present. Even down this sulfur will be present. Okay. Actually, these are the positions of the elements in the periodic table. Okay. So, but what we discussed, top to bottom electron affinity values increases and decreases. Top to bottom atomic size increases, so electron affinity values decreases, right? So the highest we may expect in the case of these two, because they belongs to second period, these two belongs to third period. So top to bottom electron affinity decreases. So our answer is in between carbon or oxygen. But while they are moving from left to right in a period, what about electron affinity? We learned that when we are moving from left to right in a period, electron affinity increases. Okay? So, carbon will have less value compared to oxygen. So, can we choose oxygen as our answer? No. That is what we discussed previously. You written in the notes also as a note. Out of oxygen and sulfur, which is having more electron affinity, sulfur is having more electron affinity compared to oxygen. The reason for that is same the reason whatever we discussed in the case of oxygen and sulfur also. Okay? Understood the logic? What is the reason we discussed? Due to small size of oxygen, there will be more inter-electronic repulsions. Due to more repulsions, the electron cannot be added quickly to the outermost orbit. But in the case of sulfur, the inter-electronic repulsions will be less. So whenever the electron is added, it releases more amount of energy. Okay? Now coming to next question. Which of the following has a positive electron affinity value? Now, let us look at the options. Oxygen, fluorine, nitrogen and the carbon. Okay? So these are the four elements we given. Regarding the positive electron affinity value, what we discussed, we know that the second electron affinity value of any element is positive. That is what we already discussed. And one more regarding the positive values is, out of all the elements, noble gases will have less tendency to gain the electron. So that is why in the case of noble gases, we need to supply energy to add the electron. So that is why the process will be, where supplying energy means the process will be endothermic. So So it will have positive electron affinity value, right? So out of the four options, is there any noble gases present? No. Okay? So all these are not the noble gases, right? Then which is having the positive electron affinity value? Here, focus on nitrogen. Nitrogen atomic number 7 and its electronic configuration if you observe 1s2, 2s2, 2p3. So in the case of nitrogen if you observe it is having half-filled electronic configuration, right? So due to its half-filled electronic configuration it will have more stability. Okay, so when we add one more electron to this one, it loses the symmetry in its electronic configuration. Correct or not? So the nitrogen, if we add one more electron, it will become 2p4. So one more electron will be added. So it loses its symmetry. Nothing but it loses its half-filled configuration. Okay, means it loses its stability. Nothing but many times we discussed it. No element wants to lose its stability, right? So that is why in the case of nitrogen, here to add the electron, small amount of energy is gained. Okay, so that is why the electron affinity of nitrogen, is slightly positive. Okay, so very small energy will be released, even it is nearly zero, just more than zero. So the value, electron affinity value of nitrogen is slightly positive value. Okay, note down this and highlight this point also. What you will the electron affinity of nitrogen is slightly positive. Now, look at one question. Which of the following process releases energy? Okay, or even instead of writing clearly as releases energy, now I am saying it as which of the following process is exothermic process? Okay, which of the following process is exothermic? Exothermic means energy will be releases. So look at the options. I think this is the third question. So observe the options. Okay. So these are the four options that are given. Now the question is, out of the four options, which is exothermic process? Okay. So already in the last class we discussed exothermic means what? Energy is released. Okay. Endothermic means energy gained. These are required. Now let us take the first option. If you observe the first option, here from X minus one electron is removed. Correct or not? Previously its charge is x to the power minus 1. So from that anion, one electron is removed. Okay. So to remove anything, definitely some amount of energy is required. Correct or not? To remove the electron from that, any atom or ion, definitely it requires energy, which generally we call it as ionization potential. In detail, we already discussed about ionization potential. So you know, energy required means this process is endodermic process. Okay. Now, in this case, same as like the first option. In the case of fourth option also, one electron is removed from the minus 2 charge ion. Okay. So one electron is removed. So minus 2 became minus 1. Okay. So in this case, electron is removed. So electron is removed means ionization potential. So energy required. So always it will be positive value. Okay. Positive means endodermic process. So this is also not our correct answer. So option 1, option 4 ruled out. Check the option C. In the case of option C, the electron is added to the ion. Coming to the option 2, second option, the electron is added to X atom. Okay. So both the cases electron is added. So the corresponding energy we call it as electron affinity. Right? So both the cases, option C as well as option B, both cases electron is added. But out of the two, only one we have to choose. Means only one is exothermic, the other is endothermic. I hope most of you got the answer. Right? Can we choose this option C as the correct answer? Can we say this process is exothermic? No. This is not exothermic. This is also endothermic process. Why this is endothermic process? Because that is what we already discussed. We are adding a negatively charged ion to the negatively charged electron to the negatively charged ion. So there will be repulsions. So to overcome the repulsions, some energy should be supplied. So this process is also endothermic. But coming to this option, we are adding the electron to the neutral atom. So when electron is added to the neutral atom, definitely some amount of energy will be released. So this process is an exothermic process. Okay? Understood, Amma? No doubts here. And even by observing this, so from these options, we can mention one more thing. Here, if you observe option A and option B, what? If you observe these two options, here, x plus electron gives rise to x minus 1. Okay? So the corresponding energy released, we call it as electron affinity. The reverse process. Reverse process means from x minus when we remove electron, the corresponding one is when electron is removed. This is corresponds to ionization potential. Okay. So remember, the electron affinity value is a negative of ionization potential. Okay. Means negative in the sense opposite to the ionization potential value. Okay. Correct or not? When electron is added to the outermost orbit, how much energy is released is exactly equal to the amount of energy required to remove the electron. So even in a better way, we can represent this one as electron affinity of x is equals to ionization potential of x minus 1. I hope you understood this one. Understood, Aman? Electron affinity of X is equals to, here X minus to X. From the X minus, ionization potential means what? Energy required to remove the electron. So that will be same. Okay? Copy this. Till now we discussed about electron affinity as well as ionization potential also we discussed, and even atomic radius variations, everything we discussed. Now coming to the next periodic property, it is a very easy one to understand, that is electropositivity. Okay, electropositivity. So these electropositivity as well as electronegativity are regarding this correspond mainly related to this ionization potential as well as electron affinity. Okay, so here electropositivity, first note on the definition, then we will discuss in detail. It is the tendency of an atom to lose the electron. Okay, electropositivity is the tendency of an atom to lose the electron. Okay, so it is not a measurable value, because when energy is released or gained means we can measure, but it is what? It is not the energy, it is just the tendency of an atom. Generally, every one of us, we say simply we like Taj Mahal. How much we like means can we measure? We may say this much, that much. Okay, so we cannot measure that tendency of love. Everybody are watching this cricket matches. So if anyone asks who is your favorite cricketer, means we say Virat Kohli or MS Dhoni, simply we say. How much means can we say? In liters or kilograms can we say I like Virat Kohli in these many kilograms. Okay, so same way electropositivity is the tendency of an atom to lose the electron. Okay, so we cannot measure this electropositivity. So the units for electropositivity, if they ask, it will don't have any units. Okay, to measure the electropositivity there will be no units, so you cannot measure electropositivity. Okay, just it is the tendency of an atom to lose the electron, right? But regarding the electropositivity, we may compare, means when compared to other atom, how much we like this. For example, out of the two members, we may say we love this person Virat Kohli more than some other X. Okay, so in the same way, when you compare two elements, for example X and Y elements, if you take, so out of the two, which has more tendency to lose the electron, we can find. Okay, but not the exact value of electropositivity, right? So note down the definition carefully and mention in the notes as it don't have units, because it is tendency of the atom to lose the electron. Generally in the periodic table, which elements has more tendency to lose the electron? Okay, generally we all know that the elements which have more tendency to lose the electrons are named as metals. Okay? So mention that point also in the notes. Metals are highly electropositive elements. Okay? Generally metals have more tendency to lose the electrons. So that is why those are highly electropositive elements. Okay? Non-metals means they will have more tendency to gain the electron. That we call it as electronegativity. In the next class we will discuss about that one. Regarding the electropositivity, mention this point. Metals are highly electropositive elements. Now let us discuss about the variation of electropositive nature or electropositivity. Now first, in groups. Before discussion about in groups and periods, first let us look at the relation between electropositivity and the atomic radius. As we all know, when the size is large, so this is small size atom, this is large size atom. Regarding electropositivity, the ionization potential we discussed. When the size is large, the distance from the nucleus to the outermost orbit is more. And then the effect of nucleus on the outermost orbit will be less. Okay? Correct or not? So means the nucleus cannot attract the electrons in the outermost orbit very strongly towards it. Okay? But in the case of small sized atom, the distance is less. The effect of nucleus on the outermost orbit is more. So the nucleus attracts the electrons strongly towards it. Okay? So when these electrons are strongly attracted towards the nucleus, so can the atom loses electron easily? No. Okay? But in the case of large sized atom, the effect of nucleus on the outermost orbit is less. Okay? Means the nucleus cannot attract the electrons strongly towards it. When it is not able to attract the electrons strongly towards it, indirectly we can say it will be very easy to remove the electron, or it will be easy to lose the electron. Right? So, more the atomic radius, more will be the tendency to lose the electron. So, we can say electropositivity is directly proportional to the atomic radius. Okay? So, as atomic size increases, the distance from nucleus to outermost orbit increases. So the nucleus cannot attract the electron strongly towards it. So indirectly it will have more tendency to lose the electron. Okay? So as the atomic size increases, electropositive nature also increases. Okay? Now let us discuss about the variation in groups. As we all know, along the groups top to bottom, atomic size increases. So electropositivity increases from top to bottom in groups. Okay, electropositivity increases from top to bottom in groups because atomic radius increases. atomic size decreases. So electropositive nature also decreases. Electropositivity decreases from left to right in periods. Okay? In the periods, electropositive nature decreases from left to right because atomic radius decreases. Okay? So, in the period if you observe, so the extreme left hand side, so left to right electropositivity decreasing means which group will have more electropositivity? These left hand side groups. Okay? So which group elements will have more electropositivity means the first A and the second A, nothing but alkali and alkaline earth metals. Alkali and alkaline earth metals have those two group elements have high electropositivity. Okay? Left to right it is decreasing. So the left side, extreme left side, we have S block elements. S block elements means what? This first A and second A group elements, they will have more tendency to lose the electron. This is one of the characteristic property of S block elements. Okay. Out of the first A and the second A, which will have highest electropositivity? It is very clear. The extreme left hand side. So first A will have more electropositivity than second A. Okay. Now another question. Out of first A. So first A is having highest electropositivity when compared to the remaining elements in the period. Right. Now which element is having highest electropositivity? Top to bottom in the group, what is happening? Electropositivity increasing. Okay, so it is the bottom element, francium. But I told you francium is a radioactive element. So note down very clearly in the notes. Cesium has highest electropositivity. Okay, out of all the elements in the periodic table, the element with highest electropositivity is cesium. Okay, so it is an alkali metal that will have the highest electropositive nature. Means not only in the group but compared to all the elements in the periodic table. Okay, electropositivity is an easy thing, right? In the next class, we will discuss about electron negativity and other periodic properties. Okay, thank you.